On this lovely day, let's go ahead and attack. We are going to talk about our best friend, similar. Now that we've talked about congruence, and now that we looked at polygons, we are going to spend some time looking at what's similar polygons. So by way of introduction, you are standing at a building, not to scale, clearly not to scale here. You're standing 15, so that's you right here. So I'm just going to zoom in right there to see what you look like. Oh, look, you lost some weight. Okay, now you are standing there and you're 15 meters from one, and of course, how do you know you're 15 meters? Yeah, of course, you have a tape measure with you, right? And then you have a tape measure with you, because who doesn't carry around a tape measure, right? So now you have that. And of course, how do you know that this was 90 meters? Heck, you just fell off the building, so good thing. So now you know all of these measurements, because you do. Awesome sauce. So our job is to find the height of the building, B, right here. So this guy here related to this guy here. So this is my unknown x. So x over 90 should be the same as what? As 50 over 15. Now, exactly why? Today, and you may have solved this stuff in pre-algebra many, many moons ago. And so there are reasons why that's true. Your instinct is right that we can set up a proportion. But today, and when we get to our next lesson, we're going to see why that's the case. Why am I allowed to? Before I even attack Keel, I'm going to go ahead and simplify those two because I like to deal with smaller numbers. So that's 10 over 3. So now when I cross multiply, this gives me 900. And then this gives me 3x. And so clearly, x is going to be 300. Now when I bring it back into the real world, like a complete sentence, find the height of the building. And I could say something like this. The building is 300 feet high. Tall. Now, meters. It is meters. Meters tall. Clearly this is not drawn to scale because B should be triple the height, more than triple this height right there. So let's take a gander here. Congruent polygons are polygons that have what? Good. They have congruent sides, corresponding sides, and congruent corresponding angles. Now remember what each piece of these does. The corresponding angles being congruent tells you it's the same shape, that these two objects have the exact same shape. Whew. All right, so thus this tells us it has the same size. Yep, same shape and then same size. So what does similar polygons mean? Now it turns out congruent is a subset of similar. So congruent polygons, similar polygons, are polygons that have congruent corresponding angles, which means they are two objects that are the same shape. But sides are in proportion. Sides are in proportion. What this tells me is that they have the same, might not be the exact same size. One is smaller than the other. So an action figure based on me. The scale factor is just one of the ratios. Whatever the ratio is of the proportion, then that is the scale factor. So let's take a gander at our first example here. We're told that these two polygons are similar, and what we did was spend some time talking about congruent statement. Not a congruent statement, but a similarity statement. So please change that as I learn to spell. So the similarity statement uses this symbol, the tilde. If you are in Spanish, you could say that. And we simply say something like this. The order does not matter. Alphabetical order does not matter. A, B, C, D. But what we're doing is going from corresponding to corresponding. Make sure the vertices are corresponding. This A right here corresponds to this one because I'm going to the next right angle, not necessarily up. They don't have to both be up. But I'm going from right angle to obtuse angle. Right to the obtuse. So that's the order I'm following, consecutive A, B, C, D. So the other one would be G, H, I, J. So that would be a similarity statement, which is very similar to the congruent statement. Now, statement of proportionality, that gets a little bit crazier. So this is going to be an extended proportion. It's an extended proportion. Just to give you a heads up, it is so much easier when we have numbers here because there's far fewer things to write down. But since AB corresponds to the GH, I'm going to make a fraction out of that. So for proportionality statement, I'm going to say this. AB over GH. That right there, by the way, gives me the scale factor from the small compared to the big. Now, that is going to correspond to this, the BC divided by HI, etc. So we can keep going. We have the CD over the IJ, and lastly, the AD over the GJ. Good, make that change there. I got too excited about my C's. All right, HI for that one. And again, each one of these is called my scale factor once we simplify it. All right, and lastly, the congruent angles. We can just mark that up real quick. And notice that once you have this in order, the congruent angles are already given. Angle A is congruent to angle G. Angle B is congruent to angle H. C is congruent to I. And D is congruent to J. So if I fill that out, angle A is congruent to angle G, J. So these are my corresponding angles, and they are straight congruents. Straight congruents. Now, just a note about the proportion or the statement of proportionality. We don't need to write all four fractions out. Remember, sometimes we're just considering these two and then do cross multiply. We could just consider these two. We could just consider these two. The key is whatever one has lots of information. If this has both numbers, then we can start finding any missing things. So let's look at it and take practice real quick here. All right, the instructions on the previous page for this one said, how do you determine if these are if these are similar? So pretty much we just need to know, does it fit the mold? Does it fit the definition? Do we have corresponding angles that are congruent? And are the sides in proportion? So this one's just about doing a fraction a bunch of times, okay? So congruent angles, that's a straightforward one. And notice here, I can see that C and Q are congruent. Then I see that angle D and angle R are congruent. Angle E and angle S are congruent. And lastly, by default, even if you didn't know that, even if it didn't mark it, they have to be congruent. So F and T are congruent. So I'll just make that list real quick over here, just so that we have the proof part in play. So angle F is congruent to angle T. Next, angle C is congruent to angle Q. Next, angle E is congruent to angle S. And lastly, angle D is congruent to angle R. Now here's the fun part. So I'm just going to check to see if the corresponding sides are in proportion. So notice the CD here is 3, and that corresponds to this 4 over here. So that fraction is 3/4. Now I'm going to keep going. This here gives me a 6 over the 8 there. I'm going to go ahead and reduce. Oh, look, 3/4, 3/4. So far, so good. In other words, they reduce to the same fraction. So far, 2 of them do. I'm going to, all right, and again, 3 over 4. Yay, 3/4. So there's my third one, and my fourth one here is 6 over 8, also equals 3/4. So 3/4 equals 3/4 equals 3/4. You can treat it separately like I did, or another way to do it is just write that extended proportion and just reduce it underneath. For example, this. 3/4 equals question mark, 6/8 equals question mark, 6/8 equals question mark, 3/4. And then 3/4 equals 3/4 equals 3/4. Guess what I'm going to say next? 3/4. There we go. Good. So because of that, written as an extended proportion, we see that it is, in fact, proportional. So the sides are in proportion. The angles are congruent. So the answer here is determine similarity. Yes, they are similar. And you can use this tilde there just to speed up the similarity word. So let's look at the next one here, congruent angles. Well, first off, what's the measure of angle C here? What's the measure of angle C? Anybody? Thanks. Sorry, it's too much talking there. How about this one over here? 88. So far, so good. We quickly see that angle B is congruent to angle H. So if you were doing a proof for it, angle B is congruent to angle H. You're making your list, and then etc., which is something you just quickly see. It's not even something that... so much stuff about geometry is that you see it, but when you actually have to write it out, it takes like half your lifetime. Angle J, and then finally angle C is congruent to the other one. The other one. You guys know that? Nope. It's actually the ugly one, but it's Teen Girl Squad.
What?
No? Let's now consider about small, medium, and large, because that's the biggest thing to consider. So notice, we don't say 6 connects to 6. Just because they're both the same, that's not actually the case. 6 connects to 4, right? Because the smallest over here is 6, and the smallest over here is 4. So the small compares to the small. So this here gives me 3 halves. All right, so here we go. 9 is the middle over here, and 6 is the middle here. So 9 over 6 is 3 halves. Yay! So now let's go 12 over 8. 12 over 8, and that gives me 3 halves. And since all the fractions are the same, but in an alternate universe, maybe it didn't work out, so then you would say not proportional. But over here, now we can answer that and say yes, yes, they are similar. All right. Now what we want to do is show you how to use, in the context to use it. Notice that we could have set up, just like our warm-up, when we're trying to find the height. Essentially what we're doing is determining that the objects are similar first. Then we can set up a proportion. But here, we're told that the triangles are similar. And what we're going to do now is start comparing things. Notice my right angle is at J, and my right angle here is at Q. So that means Z is going to correspond to the Z plus 4. So there's one fraction. Z over Z plus 4. Next. The next fraction is going to be the middle length, or the leg that's longer. The 3 compares to the 9. Now cross multiply is a valid method, and that's the first thing we often think of. But did you notice what you can do with the 3 and the 9 there? Might as well reduce it while we're at it. Smaller numbers make life a little bit easier. So if you do reduce that, then cross multiplication, then it'll be a little bit faster. Notice here, it's just 3 times Z. Equals, here, don't forget to distribute if you had to. The 1 doesn't need to distribute, so I can effectively just write Z plus 4. Now I'm going to subtract Z from los lados to get this. And then in the end, I have an answer, Z equals 2. Now, let's see what the question says. It asks us to find the value of the variable, so we're done there. But how do we know we're right? Well, I'm glad you asked. So what we need to do now is take the 2 and plug it back into the various places. So 3 over 9 is equal to 2 over 2 plus 4. Question mark. Now, if we do cross multiplication here, we might make the same mistake that we may have made over here. What do I mean by that? All I'm saying is a check is best done if we do a different method, just in case there's some sort of mistake that's occurring over here. So now if I just reduce this by 3 and reduce this by 3, reduce this by 2, reduce this by 2, oh look, it is indeed 1/3 equals 1/3.